Hello friends, today we will discuss about the surface tension that is denoted by sigma. So the surface tension is the apparent tension accepted at the interface of the liquid gas liquid interface. So it is a property of the material of the liquid, and it is due to the unbalanced cohesive forces of the liquid, and surface tension is due to the cohesion. Okay, so let's try to understand what is surface tension. Okay, so this is the consider this is the liquid gas interface. So this is the liquid gas interface. So consider this is a liquid gas interface. So here this portion there is a gas, and here there is a liquid are there. So here there is a liquid. Okay, so consider the liquid molecule. So here there is a liquid molecule, there is a liquid molecule here, here. So there are liquid molecule here also, there are liquid molecule, and outside that interface there are another gas molecule. Okay, because outside this interface there is a gas, so this is a gas molecule. Okay, so the attraction between same molecule is known as cohesion. Okay, if there is a attraction between the same molecule, the attraction between the same molecule is known as cohesion. But at the interface here there is a liquid molecule, and outside this there is a gas molecule. So when there is a dissimilar molecule attraction are there, then the liquid gas interface are created. Okay, so first we will write the what is cohesion. Cohesion force means cohesion means that is same molecular attraction, that is same molecules attraction. Okay, and adhesion force means dissimilar molecules attraction. Dissimilar means different, dissimilar molecules attraction. Okay, and remember this data, that is sigma surface tension, that is denoted by sigma, that is H2 air interface, that is equal to 0.072 Newton per meter. Okay, and for Ag air interface, so sigma for Ag air interface, that is 0.49 Newton per meter, and sigma for Ag and H2O interface, that is equal to 0.42 Newton per meter. So these data are important. Okay, so here this attraction is known as adhesive force. Okay, so let's try to write the surface tension definition. So the definition is that, so it is the apparent tension, it is the apparent tension accepted at the interface of the liquid gas, accepted at the interface interface of liquid gas or liquid okay. So it is a property of the fluid. It is the property of fluid. Okay, so it is due to unbalanced cohesive forces of liquid, and it is due to unbalanced cohesive forces of liquid. Okay, so surface tension is due to cohesion. Okay, you can write that this surface tension is due to cohesion. So surface tension is due to cohesion. Okay, so if you add the impurities, then surface tension increases, and detergent is also decrease the surface tension, but salt increase the surface tension. And surface tension is the surface energy per unit area, and surface tension is the normal force per unit length at a liquid surface. Let's write that impurities increase surface tension. So impurities increase surface tension. Okay, detergent decrease surface tension. So detergent decrease, very important, decrease surface tension, but salt SaLt, that is NaCl increase surface tension. Okay, and surface tension is the surface energy per unit area. Remember that surface tension is the surface energy per unit area. Okay, and surface tension is also known as surface tension is the normal force per unit length at a liquid surface. So surface tension is the normal force per unit length at a liquid surface. Okay, so how? So here consider this is area. Consider this is area. Here this is A1, the area is here. This is A1 area, and for A1 area the surface energy is E1, that is equal to sigma into A1. Okay, sigma is the surface tension. Okay, now there is another area. So this is the large area as compared to the A1. So this is, consider this is area A2. this is A2, and this area is larger than A1. So what is the surface energy E2? That is the sigma into A2. Okay. So work done. So if you want to calculate the work done, okay, to create the area A2 minus A1. So this is, so if you want to create the area from A1 to A2, so what work done is required for that? So if you want to calculate the work done to create area, that is E2 minus A1, that is equal to E2 minus E1. Okay, so this is E2 minus E1. So that is equal to sigma A2 minus sigma A1. So sigma into A2 minus A1. Okay, so W, that is equal to work done, that is W. So work done W that is equal to sigma into A2 minus A1. Okay, from here sigma, that is equal to W, so W by A2 minus A1. Okay, now if you want to calculate the unit of this surface tension, so surface tension sigma, that is, we know that from the definition, that is surface energy per unit area. So surface energy per unit area. So surface energy, that is, this is the energy. Okay, so surface energy, that is the unit of joule, and area meter square, and joule we know that Newton into meter by meter square. So from here we can say that this is Newton per meter. So this is the unit of surface tension. This is the unit of surface tension sigma. Okay. So now for the given volume, spherical geometry has minimum surface area. So that is why more stable geometry, so liquid, droplet and bubble are naturally spherical. So as the minimum surface area of spherical surface, that's why the liquid, droplet and bubbles are naturally spherical. Okay, so here this is the suppose this is the liquid here. So this is the liquid droplet here, this is the liquid droplet, and here this is the liquid, this is the liquid. So ES, if you want to calculate the ES, that is surface energy, that is, we know that sigma into AS. So sigma into what is the spherical area, 4 pi r square. So this r is the radius of the sphere. Okay, r is the radius of the sphere. And suppose consider, and this is soap bubble. The air inside this, here there is the air and there is a layer. Okay, so this is soap bubble. So here consider the inner area. So here the Ri, and this is the radius Ro. So consider Ri that is inner radius, that is outer radius, outside radius, that is equal to r. So es, if you want to calculate es, surface energy, that is 4 pi 4 pi ri square into sigma plus 4 pi ro square into sigma. So from here you can say that is 8 pi r square sigma. Okay, so you can say that 2 pi into 4 pi r square. So es, that is the 2 pi into 4 pi r square. Okay, so this is the surface energy. So consider, so this is one soap bubble, this is one soap bubble. So the energy of this soap bubble, that is equal to 2 pi 4 pi r1 square. So consider this is the radius r1. Okay, so this is, and if there is another soap bubble, there is a large soap bubble. Okay, large soap bubble. If you want to create this small soap bubble to large soap bubble, so here is the energy, that is 2 pi. So consider here is the radius r2. Okay, 2 pi into 4 pi r2 square. Okay, so if you want to calculate the work done, so work done W, that is equal to, so E2 minus E1. So E2, that is 2 pi into 4 pi r2 square minus 2 pi into 4 pi r1 square. So this is 8 pi. So sigma is missing here, so sigma is missing 4 pi, and there is sigma is missing here, so sigma and sigma. So here also there is sigma and sigma. So so this is 8 pi sigma into r2 square minus r1 square. Okay, so this is the work done formula for soap bubble. Okay, now there are one question. So a spherical water drop of radius r split up to in air into n smaller drops of equal size. So here in question there is a spherical drop, and this spherical drop, it converted a small drops of liquid. So n number, so this is n number of drops of liquid. The work done required in splitting up the drop. So what work done is required, you have to calculate the what work done is required to splitting up the drop. Okay, surface tension of water is given, that is sigma. So surface tension of water given. So from question you can say that volume of large droplet, that is equal to volume of, so this is n times volume of small droplet. Okay, so consider the large droplet radius, that is r. So large droplet radius, that is r, and small droplet radius, that is small r. Okay, so what is the volume? That is 4/3 pi r cube, that is equal to n into 4 by 3 pi r cube, small r cube. So from here you can calculate that r equal to r by n to the power 1 by 3. Okay, so now if you want to calculate the work done, okay, if you want to calculate the work done, so work done W, that is equal to E2 minus E1. So that is equal to E2, that is n sigma into 4 pi r square minus sigma 4 pi small capital R square. So from here, that is n pi into 4 pi. What is the value of r? That is r by n to the power 1 by 3. So r to the power 2 r n to the power 2 by 3 minus 4 pi sigma r square. So from here you get 4 pi sigma r square into n to the power 1 by 3 minus 1. So this will be our answer. This will be our answer. So okay, so this is all about the surface tension concept. Okay, thank you.